Alright, welcome to another AQA A-level chemistry video. Today I'm going to be doing a video on really some exam questions on acids and bases and buffers. Now I put the marks here and then you're going to see them throughout the entirety of this video, and that's how much you should spend on the video. But this isn't me going through exam questions in exam conditions. I can do it in exam conditions because, as I said, I already have done my A-levels already. So me doing this, it's not really necessary for me to do it in exam conditions. Today I wanted to actually go through it, just explain how to do it, because I haven't actually explained how to actually do some of these questions. And someone actually said if they can actually, they messaged me saying that could you actually go through how to answer these questions. So this is what I'm going to do in this video. I'm actually going to go through how to answer some of these questions. This is going to be part one of a 2-part series of videos, or maybe a 3-part, probably a 3-part, maybe 4-part. But there's a lot of types of questions surrounding this type of content. I'm going to break it down, each part of it, and I think the best way for me to do that is not to constrict myself to time conditions, because I can't speak and write as quickly when I'm doing that. So I just want to go through every single part. So the first one is calculated pH of a strong acid. Now I've already done this in one of my videos. I explained how to do it, but it's just, I told you that the information we know is that for calculating the pH of a strong acid, now we know that to calculate the pH, we need to have the H plus concentration, right? We need to have the H plus concentration to work at the pH. Now, the thing we all understand from strong acids is that strong acids strongly dissociate H plus ions in solution. And one of the things that I said in that video in relation to strong acids is that because they strongly dissociate H plus ions in solution, right? If I made this equation, we all recognize this equation here, right? HA. HA represents an unionized acid, dissociating to H plus A minus. If equilibrium is far to the right, that's what a strong acid is, right? It strongly dissociates H plus ions in solution. We can therefore assume that the concentration of HA, or unionized acid in solution, is the same as the H plus concentration in solution, because it fully dissociates in solution. So whatever this concentration is the same as this concentration, because this has fully depleted, or fully dissociated with depleted. When I mean depleted, it means fully dissociated. Its concentration has become depleted, but it's depleted because it's fully dissociated in solution. So all of this has dissociated into H plus and A minus. In this case, the most important part is that it's fully dissociated H plus ions in solution. So we have nearly a full concentration H plus. In solution of a strong acid, you'll never find the acid as HA in the unionized form. It'll pretty much always be in the H plus identity. It will just be H plus in solution. Therefore, we can assume that the concentration of HA in our solution is the same as our H plus concentration for strong acids, because of this equilibrium being far to the right. Therefore, we can make the assumption that because we know that H plus concentration is the same as HA, we can just use that directly. So to work out the pH of HCl, because HCl is a monoprotic, again, this is for monoprotic acids, right? Monoprotic acid. Diprotic acid is the same principle, but we have to double our H plus concentration because we have doubled the amount of H plus. Triprotic, same principle, would be triple. So if you want to calculate the H plus, the pH of 0.25 moles per dm cubed of HCl, right? It'll only take you a minute. Look, it's three questions here, and it's 3 minutes, because each question should only take you even less than a minute, really. But it's only 1 mark per question, because all you're doing is pH is equal to minus the log. Remember, pH is minus the log, base 10. The capital L represents base 10, right? So this is the same as this, whatever you have there, right? Of 0.25, because remember HCl is a monoprotic acid, so it'll be this in solution, right? H plus. That's a terrible H, sorry, my bad. H plus a Cl minus. Therefore, it's just that. And then our pH of HCl, pH of 0.25 moles per dm cubed of HCl is just put that in the calculator, minus log base 10 0.25, it should be 0.6, which would make sense, right? Our pH of 0.25 moles per dm cubed of HCl is 0.60. Three significant figures there, giving us three significant figures there, or two significant figures in our question. So we use two significant figures in our answer because that's the smallest amount that there. So 0.6, does that make sense? Yes, because HCl is a very strong acid, so it's going to be close enough to 1. 0.25 moles per dm cubed of an acid, yes, of a strong acid. 0.25 moles is actually quite high. In classrooms, you usually use around 1 or 0.1. Probably a little bit lower than that sometimes because HCl is a very strong acid. So this makes sense. 0.6 makes sense. Now, that's very easy. Now, how do you do the... Again, if you find some of these questions easy, I've got much harder, slightly harder questions going on. If you already know how to answer these questions, please just move on. I'll try and do timestamps for this video. Hopefully, I have done timestamps for this video. But these types of questions I know are probably, if they're easy for you, fine. If you don't get this second part in relation to triprotic and diprotic acids, I'll go through that. So the second one is B, right? So that was part A for that question. Let's do the part B now. So the part B is probably going to be a bit harder because it's triprotic, right? But remember, keep the same principle in mind that H3PO4 is triprotic. Now it's not that it isn't directly going to 3H plus and PO4 minus, but it does inadvertently just lead to this. Actually, it breaks down. It likes to do it in stages. So when it comes down to diprotic or triprotic acids, they do eventually just get down to 3H plus or 2H plus, but they usually do it in stages. So if it's a H3PO4, it prefers to actually go into H2PO4 whatever and then do it that way, right? But eventually it does it in multiple steps, right? But eventually I'm gonna go down to final step really. 3H plus PO4 3 minus, right? Something like that, right? It should be, yeah, that makes sense. And that is, I don't know if this is the PO4 3 minus. It should be 3 minus because it's 3H plus here, right? But the point being, right, this is spectators. We don't care about that. The part we care about is this 3H plus. Again, this equilibrium is far to the right. If this is wrong, sorry, I'm not bothered to actually probably check it because it's not really relevant to me right now. If it's actually an exam question where they ask for the association, then I actually care about it. But here we're looking for to calculate. Now, how would we calculate this, right? Same principle. We know equilibrium is far to the right, so we can assume the H plus concentration is the same as the acid concentration. But we have 3H plus now instead of 2. Therefore, all we're changing from this equation here about the minus log H is that pH in this case is equal to minus log, and our concentration H plus is 3 times larger, right? So all we're just doing is 3 times by the H plus concentration. That's it. Because we have 3 times as many H plus in our solution, so our concentration is 3 times as large. Therefore, the pH of 0.25 moles per dm cubed of H3 for phosphoric acid, right? H3PO4 is just minus log base 10 of 3 times by 0.25, which is going to be 0.75, but you can already see that there. And that is equal to... Now, I'm expecting this answer to be lower than our previous example, right? Yes, it is. And that would make sense, right? It does make sense. This should be lower than HCl because they're both strong acids, but HCl is monoprotic, whereas H3PO4 is triprotic. So we'd expect H3PO4 to be more acidic because it's dissociating more H plus ions in solution. Therefore, although they have the same concentration, really the H3PO4 is more acidic because it's dissociating more H plus in solution. So it's technically more concentrated in this example here because it's dissociating more. In an ionized form, they're the same concentration. In the dissociated form, which is really what's happening in our solution because it's a strong acid, technically H3PO4 is more concentrated, and it's shown here because it has a much lower pH, representing a much higher acidity. And the last one here, which is I want you, now I've done those first two. I want you to try and do that question. So I'll give you 1 minute now. Pause the video now. Try and answer that last question. It's on sulfuric acid there. Alright, okay, I'm assuming that you've paused the video and you tried to answer that question by yourself. So let's go for the part C now. So pH of H2SO4. H2SO4, strong diprotic acid, right? So that's gonna go. By the way, you don't have to draw out the equation because it's just 1 minute. I just want you to literally, all they're asking you to do is this. That's it. And in the mark scheme, really you have to just write this to get the mark, but always write out how you work out. In A level, you always have to write out how you work out your how you calculated it. In GCSE, they don't really care about it that much, but in A level, you have to show that. Otherwise, they don't give you the marks. So this is just going to associate into 2H plus SO4 2 minus, right? And then that's just going to be same principle, right? But it's just going to be 2 times now. So minus log 2 by what's our concentration? 0.05 moles per dm cubed. So 0.05, and that's it really. Or 0.1 really, I should just say. Minus log base 10. So minus log base 10 of 0.1, and that's 1 as pH of 1, exactly 1. I'm not going to write out two significant figures. So again, well, technically it's one, and it's in this example it's actually just one significant figure, so you can just leave it as 1. But hopefully that part's pretty. But I think that part's quite easy. I think everyone gets that part. But some people get confused between the triprotic and the diprotic part. But it's literally very, very easy. All you're doing is multiplying them by how many protons they're dissociating. If you don't know how many they're dissociating, it should be quite obvious from here. You see H3PO4, H2SO4, HCl. But if you want to write out the equation, do out the equation. You can see how many acids how many protons you're dissociating. That tells you what type of acid you're that helps you out in your calculation. Now the part D and E is now you should, if you did not revise my video, if you looked at that video and I talked about strong acids, then this is also very easy for you. Now if we want to do the reverse order, right, the reverse way of calculating, we want to work out our concentration HCl from our pH. Now if you know logarithms and maths, you know how to rearrange that equation, right? But I said it in the video. If you want to work out pH, if you want to work out H plus concentration from pH, that's a terrible square bracket. Then we just do 10 to the power of minus your pH, and that's it. And that's literally all you're doing here. And that's why it's only 1 mark per question. So concentration HCl. And if you're worrying about, I'll do a second part. So H plus is equal to 10 to the power of. Now I'm expecting this to be very, very, very low because our HCl is acidic in this case, but it's not very acidic, very weak, weakly acidic, and that's quite confusing because our solution of HCl here is very, very, so say HCl is very strong acid. HCl is a very, very strong acid, so we'd expect it to be quite low. So this tells me, because it's only 5.8, this tells me that it's very weak in solution, or it's very low concentration HCl in solution. So I'm going to shut up now and actually answer the question, right? Because you probably just don't care about me speaking too much. But minus 5.8, right? But I'm expecting this to be very, very low, and it is. So 1.58 times 10 to the power minus 6 moles per dm cubed. Never forget to write down moles per dm cubed. If they might just give it to you when you're answering, but that's it. Which is what we'd expect, because pH of 5.8 is quite high for a strong acid. So that tells me that it's going to be a very low concentration HCl in solution, given that HCl fully dissociates. The second one doesn't make too much sense to you, because H2SO4 is arguably a stronger acid than HCl because it dissociates 2H plus in solution compared to 1. But its pH is more basic, right? So what does that mean? What this means is that you probably have a base in your solution, or more base in solution than acid. So this may be an acid-base titration, and now you're You're just working out the concentration of H2SO4 in this solution that may have more base in it. So that's what I see. Is now, again, you don't need to worry about that because you're not here looking for that. But how they go about answering this question, like this: H plus is equal to 10 to the power of. You don't need to do anything special for this because you're just working out the H plus concentration. That's all you're doing from this. So H plus is equal to, and you think sort of don't have to times it by 2 or anything like that because it's H2SO4, it's diprotic, right? No, the H plus concentration is constant for this entire equation because it's just working out the concentration of H plus within that pH that they're giving you. If the pH of 2, think about it, right? Think about this example here, right? If we have two concentrations here that are the same, but the pHs are different. But that doesn't necessarily mean if the pHs are the same, we'd expect two different two different H plus concentrations. No, if the pH is if the pH is a certain value, it will always correspond to that specific H plus concentration. If you have a concentration of 5.8, if I have a pH of 5.8 of HCl and also the same pH of H2SO4, they'll both have the same H plus concentration in solution, right? Because they both have, in order for it to classify as pH, it has to have the exact H plus concentration. So don't get confused because I see some people, they get confused between when they see H2SO4 and working out the H plus concentration if they have the pH. You don't have to do 2 H plus equals 10 to the power of minus. I'll say the reason why, because I saw someone doing this, right? So 10 to the power of minus, no. If the H plus concentrations are always constant for that type of pH. So if the pH is 9.4, then H plus concentration, you just the same H plus concentration, right? So wherever that is, so 10 to the power of minus 9.4. Again, this is expected to be quite low, so minus 9.4. Yeah, and it's going to be lower. Yeah, I expect this to be very low. So this is 3 point. Now actually, I want to change this answer actually because I think I did this to 3 significant figures and it's only meant to be to 2. So this one is technically 4.0 times 10 to the power of minus 4.00 times 10 to the power of 4.0 times 10 to the power of minus 10. Again, if you just want to skip to the questions that you really care about, just go to that. I'll try and remember to leave the timestamps for this video. What was this one again? So 10 to the power of minus 5.8. Yeah, that's fine. That's not a problem. No problem. All right, so slightly more complicated answer now we're going to calculate the pH of a strong base. Now it requires a little bit more understanding because it's not as simple, right? The POH, right? The POH is just, if we're working at POH, this would be very simple. POH is basically the same principle as pH, but just minus log base 10 of your OH concentration. And you may, and I've never seen it asked, it's not part of his, I don't think it's part of his expected ask, but if they ever asked that, that's what it is. If you had to ask that and you know it's a strong base, very simple to answer, you already know what to do. But they're asking for the pH. Don't get confused between POH and pH in this case. Now you're going to think, okay, how am I going to go about this answering this question? Now, what do we know? How are we going to work out? What do we know about the properties of a strong base? A strong base fully dissociates hydroxide ions in solution, right? Okay, so then I can just go, so NaOH, Na plus OH minus in solution. I can make this assumption because I can make the assumption that the OH minus concentration is the same as the NaOH concentration because it fully dissociates OH minus in solution. Equilibrium is far to the right. Same principle as as strong acids, but just with strong bases. Now we know that. So we can assume that we have the unionized version, and we know the unionized concentration of NaOH is 0.6 is the exact same as the OH minus concentration. Now what can we use for that information now? Remember there's an equation that we can use. We can go back to our Ka concentration, remember? So sorry, not Ka, I've gone through Ka and Kw. I have gone through KW with you. Yeah, I was just thinking if I've gone through KW with you. I've definitely gone through KW with you guys. Remember we said that the KW equation, KW is equal to H plus multiplied by OH minus. And we said that KW is a constant. KW is equal to 1 times 10 to the power of minus 14, right? Now, how am I gonna, if we know this, we know that's a constant, we have this, all we have to do is just rearrange our equation so we can get the H plus concentration, and that's it, right? In theory, that's all we have to do. So, H plus is equal to KW over OH, don't write on that, KW over OH minus. And now we have our H plus concentration. That's all it needs. So H plus is equal to 1 times 10 to the power of minus 14 over 0.6. And our H plus concentration is equal to, so 1 times 10 to the power of minus 14 over 0.6. 1 point, they've only given us 2 things, so 1.7, yeah, 1.7 times 10 to the power of minus 14, which is what you'd expect. We expect to have a very low H plus concentration because this is very basic, right? Very, very low. This sounds right. Now I say this because you always want to be looking for it, because sometimes you look at these values during your exam and you can prevent yourself. If you get a wrong answer, you can kind of see that you're going to get a wrong answer before you get to your final answer, because you always have to think during answering your question, you have to think to yourself, does this make sense? If I did this, does the H plus concentration, if you got a very, very high H plus concentration, say this is 1.7 times 10 to the power of minus 3, you got to say to yourself, there's something wrong here. I shouldn't have such a high H plus concentration. This is meant to be a strong base, right? So me seeing this just tells me that I'm on the right track, because I should have a very high, so I should have a very low H plus concentration, because this is a strong base. So anyway, now we have that. The answer's not done yet. The answer's not done yet. We've worked out the H plus concentration. We still need to do this. So the pH of this strong base is minus log base 10 of our H plus concentration, which is 1.7 times 10 to the power of minus 14. $13.8. And by the way, I've put, this is actually 1.6 recurring in terms of the H plus concentration. I put it down as 1.7. You can just put down answer in your calculator when you put that there. But anyway, the pH of this is 13.8. Now, I'm going to extend this down a little bit now. What would you go about if we're going through calculating the pH of this? This is another example, right? Same example, just because they're both strong acids, calculate the pH of 0.75 moles per decimeter cubed of potassium hydroxide. I want you to try and do that yourself in 2 minutes, right? So pause the video now and try and answer it. Okay, I've assumed you've answered the question. Shouldn't be too difficult for you to do. So the part B for this, right? So I'm going to skip all the hoorah. So that is equal to, just do this first. You probably get a mark for your conversion. Sometimes you can get a mark just for showing a conversion. Either writing it in writing the equation or substituting values into the equation. That's usually a mark. And so you get a mark for either that or actually substituting values in. So H plus is equal to 1 times 10 to the power of minus 14 over, what was it, 0.75, right? Yeah, 0.75. H plus concentration is therefore equal to 0. So either one of these is a mark. So if you forgot to write down, I'd always just write down this just in case, but you get a mark for doing either one of those. Then a mark probably for, would you get a mark? Would this be a 3-mark question? It might be a 3-mark question. You might get a mark just for writing down your answer as well for the H plus concentration. So 1 times 10 to the power of minus 14 over 0.75. 1.33 recurring, but it said we only have 2 significant figures in our question, so we can put 1.33 times 10 to the power of, now this should be lower. That makes sense. Yes, it should be lower than this H plus concentration should be it should be even lower because then our previous video, because remember this is more basic, 0.75 compared to 0.6, so I'm expecting it to be a lower H plus concentration. So 1.33 times 10 to the power minus 14 pH, therefore we have that now, is minus log base 10 of our H plus concentration. So 1.33 times 10 to the power of minus 14. Put that into a calculator. Bob's your uncle. He's not really. And then your question is answered. So minus log base 10, answer, great. 13 point, ooh, have I done something wrong here? 13.8, 13.9 really, 13.9. That makes sense. No, it should be right. Yeah, that's correct. They're similar H plus similar basic concentrations, not too different, but it should, yeah, this should be, our second one should be much higher in pH. It should be more basic. Right, so this next question now is I want you to calculate the pH of a 0.01 mole per dm cubed solution of propanoic acid, and they're giving you the Ka, the temperature is 298 Kelvin. So this one requires a little bit more thinking about it. Again, but I just want to make it clear, the temperature doesn't matter, obviously, in this case. I don't think anyone's looking at this saying, I need to, they always put the temperature in it, just to say that it's at standard conditions. Actually, no. Would I need to use KW in this example? No, it's just here to tell you that if there's any doubt about anything, because sometimes certain constants are different if they're not kept at standard conditions. The standard conditions just let you that if there's any constants that you do know, like the KW is at 1 times 10 to the power minus 14 only at standard conditions, and there are examples where they want you to calculate KW at different temperatures. But this is just telling you that it needs to be a standard condition, so you shouldn't look at the temperature saying I need to include that. It's just to tell you that it's standard conditions, right? So anyway, they want you to calculate the pH of this propanoic acid, and they're giving you that. So the first thing I think about here is that I need to work out the H plus concentration. What do I know about this? Propanoic acid is a weak acid, right? That's a weak acid. So the first thing I think about here, the first thing I write down is weak acid. I actually write it on here, or on like that, but I'm just writing on spaces. This is actually, it's something that I always note down in my question, because it just helps me to say, I can just say that we know the Ka, it should be like this, right? So Ka, weak acid means that we could dissociate H plus ions in solution, right? But Ka would usually be equal to H plus times by A minus over HA. But we know that this is a weak acid, so we can assume, because equilibrium is far to the, let me use this example here. Equilibrium is not far to the right. It's actually closer to the middle. So therefore it's weakly dissociated H plus ions in solution. And we can assume that the concentration of H plus and the concentration A minus are actually the same. So that's something that I can assume from this. Therefore, and again, I've done videos explaining why, go back to that video. I'm not going to go, this is just a video on exam questions, right? I'm not doing them in exam conditioning, because I want to try and explain to you guys. But yeah, but it's weak acid. The first thing to go is weak acid. I'll actually write down this. Weak Ka is equal to H plus squared, mind the terrible square brackets. I know that the square brackets are terrible. H plus squared over HA. That's useful because I know that's the format I need to get into. Now, they're giving me the HA, they're giving me the Ka. Now I need to rearrange this equation so I can work out the H plus. Because remember, if we want to work out pH, we need the H plus concentration. Now, rearranging this equation will be easy. H plus now is equal to the square root, the square root of Ka times by HA. And that's it. And they're giving us we already know that the Ka is what? 2.19 times 10 to the power minus 5. So the square root of 2.19 times 10 to the power of minus 5 multiplied by 0.01, and that's our answer. And this is very easy to do within, how much time to give you? 3 minutes. You can do this probably within 1.5. There you go. And it's important to try and do this in time conditions, because if you can do it in less than that time, you actually save time at the end of the exam to go through some of the harder questions that you may be struggling a bit more, or may need more time to do, or you may need time to look over it again because you made a mistake. So try and answer these questions in the time limit so that you can have more time to answer more difficult questions. So 4 point, they've only given me one significant figure there really, but 4.8. Would they go on to you for around 4.68? Let's just keep it as 4.7 times 10 to the power of minus 4. Multiplied cubed. We're not done yet. Remember, don't think you're done yet. You're done with this when you put down the actual pH. That's the question, right? That's minus log base 10 of your H plus concentration, 4.7 times 10 to the power of minus 4. I don't like the way I wrote my 1 there. And then that's your answer. So minus log answer 3.3. It's 3.33 really, but 3.3, that's our pH. And yeah, I should have wrote down as 3, this put a 0 here, because that doesn't make what it would usually have. You usually put your answer down to you look at the question, how many significant figures has, which part of a question has the lowest number of significant figures in it, right? And that has the lowest, but it should be 0.010 moles per dm cubed. That's my bad really. Yeah, but 3.3 here, that's that. I've got 2 more, have I? 2 more. Alright, cool. Hopefully that makes sense. Anyway, calculate the wait, does that make sense? Yeah, a weak acid, 3.3, yeah. Your strong acids usually are less than 2 or less than 1, like kind of so 3.3 makes sense. Now, calculate the Ka and acid concentration. Now, so we've worked out the pH. Now we're gonna try and do the reverse and work out the Ka and our acid concentration. So here's an example where they want you to work out the acid concentration, the first one, right? So calculate the concentration of the ethanoic acid when the solution has a pH of 4.04 and a Ka of 1.94 10 to the power minus 5, 4 marks. If you can do this question within 4 marks, and I think you can, I want you to try and do this question in 4 marks. It's gonna create, I think you can do it, but try and do it, right? So pause the video now and try and do it. Now I've assumed you try and done that. Now it's the same principle now, but we've just got to rearrange and look at certain things a bit differently, because we have the pH already, right? So first of all, weak acid. We know our equation is going to be in this form, right? Over our HA. Now we're trying to work out HA. That's a terrible, I had to always do HA so badly. We want to work out HA here. So the first thing I do is, after writing that down, HA is equal to H plus squared over the Ka. Now, they've given us Ka, but we don't have the H plus concentration, or do we? Because we actually do have the H plus concentration. They've given us the pH here, right? They've given us the pH. Therefore, we know that, remember, if you want to work out the H plus concentration from the pH, we know that H plus is equal to 10 to the power of minus your pH. In this case, that's what, 4.04? 4.04. H plus is equal to 10 to the power of minus 4.04. And that's 9.12 times 10 to the power of minus 5. So 9.12 times 10 to the power of minus 5. We're expecting this to be an acid of some sort, because, I mean, it already says, we already know it's an acid. We're expecting this to be not too high. We're not expecting a high pH here. We're not expecting to have a... So why did I say we're not expecting to have a high pH? That's not what... It already tells us pH. We're not working at pH. Sorry about that. Don't listen to the last thing I just said there. Just focus on what I'm writing on. I just waffled there badly. I'm really sorry about that. Anyway, they've given us the H plus concentration here. We just feed that into our equation here. 9.12 times 10 to the power of minus 5 squared now over our Ka, which is 1.94 times 10 to the power of minus 5. 9 point, what? 9 point, sorry, 1.94. Sorry, my bad. 1.94 times 10 to the power of minus 5. Our HA concentration. (4.29 times 10 to the power of minus 4). And that's that. Sorry, I don't know why I was taking long with that question. 4.29 times 10 to the power of minus 4. Yeah, I can write that, yeah. Moles per steam cubed. You shouldn't spend as long as I did. I know it's 4 marks, but you can actually spend less than that. So 1 mark there, 2. I think it should be more like 3 marks, if I'm being honest with you. 3 marks for this question, then 4 marks. But yeah, so I just got my head lost there. Anyway, that's that. The next question is B. Hopefully this made sense to you. If any of this video doesn't make any sense to you, please let me know, and I'll try and rearrange this. I'll try and explain it again, because maybe I didn't explain it in a good way. So I'm streaming at the same time, so bear with me a second. I'm streaming on Twitch, so bear with me a second. There you go. So the part B for this now. So it says we want to work out we're trying to work out the Ka. So 0.309 moles per centimeter cubed of methanoic acid has a pH of 4.81 at 298 Kelvin. What's the value of Ka? I think you can do this question. Hopefully you've done this question as well. But I can do it. So weak acid. This should be even less time because you don't have to do too much rearranging. Weak acid is equal to Ka over H plus squared over the HA. They've given us the pH, so H plus concentration is equal to 10 to the power of minus 4.81. 4.81 10 to the power of minus 4.1, 1.55 10 to the power of minus 5. Moles per centimeter cubed. Put that into our equation now. 1.55 times 10 to the power of minus 5 squared over. I'm thinking, did I square this answer in my calculator? I'll look over again. My bad. Maybe I'm making a mess of this. 0.309. Sorry, 0.309. I just want to check my last answer as well, because I think I may have not put that in correctly. Answer squared. No, I definitely did. Yeah. And the Ka here is 7.76 times 10 to the power of minus 10. Hopefully this all makes sense. And I expect a Ka for that. I would expect a Ka of this. I expect a HA like that. Let's move on. Now calculate the pK. Now this is going to be the easiest one and the last one. It's the last one I'm going to do, an easiest one, and I'll do a part 2 of this video afterwards. pK is very simple. So calculate the pK when Ka is equal to 1.09 10 to the power minus 5. Now how can you calculate pK and Ka? Now remember what pH is, right? So pH, right, in essence is the concentration, is related to the concentration of H plus. So the P is the minus log base 10 or minus, right, like that, right? So minus log base 10. The H represents the H plus concentration. So if we know that, then pKa is just pKa. If that's the case, then If pH is that, then so if pH is that, then pKa is just the minus log base 10 of our Ka concentration. And that's all we have. And that's why it's very simple. And this is, how many marks this? Should be that the first one should be 1 mark. Because it's just that. So pH and, by the way, pH and pKa are pretty much equal. I said, look at Alary Chemistry videos because he explains it much better than I have, but they are pretty much equal. So the pKa, they've given us the Ka value, right? So yeah, pKa is just equal to minus log base 10 of our Ka concentration, which is 1.09 times 10 to the power of minus 5, 1.09 times 10 to the power of minus 5. What's that now? 4.96. Our pKa is 4.96. B, propanol gas is a pKa of 3.99 times 10 to the power, or 3.99, that's pKa. Calculated pH of 0.055 moles per dm³ propanol acid. Okay, now, so they want us to calculate the pH, which means that we need to have the H plus concentration. Now, it is propanol acid is a weak acid. Again, you know what I'm going to do, weak acid. Therefore, we're going to require Ka is equal to H plus squared over our sorry about that. H plus squared over our Kj. Now we already have, we want to work at the H plus concentration. So we want to work out the H plus concentration in order to work out the pH, right? So this was the pKa. Given us propanoic acid is pKa of 3.99, H plus concentration. Looking at this right now, calculate the pH of. Oh, yeah, I was supposed to say, where's the HA? HA is literally right here. I'm so baffled. Sorry, my bad. They've already given us the HA concentration, right? So we need to rearrange this equation. Sorry, I spent so much time. It's like, where's the HA? I'm just so blind nowadays. It's that there. So our H plus concentration, we just need to rearrange this equation first. That's the first. After writing this, the first thing I do is I'd write out the rearranged equation because we need to show, we need to figure out a route to actually getting the H plus concentration. And the first thing you do is rearrange that equation. So H plus is equal to the square root of Ka times by HA. So how we haven't got K, we've got HA, we haven't got Ka. Remember, remember back to this, right? If pH is equal to that, we follow the same principle for working out the H plus concentration. Remember, the H plus concentration, I can actually pull all of this down actually. I'll pull all of this down. Ooh. If to work out the H plus concentration, we have to do 10 to the power of minus pH. It's the same principle for Ka. So if you want to work out the Ka concentration in our solution, you have to do 10 to the power of minus our pKa. And that's all we're doing here. So I hate when that happens. Sometimes I just hate my system sometimes. You're going to pull some of this a little bit back up so I give myself a little bit more space so we don't waste too much space. Pull this back up to here, right? So we have the pKa, so therefore the Ka concentration is equal to 10 to the power of the Ka value. Sorry, Ka is equal to 10 to the power of minus, what was our pKa here? 3.99. 3.99. Therefore, Ka is equal to And that is 1.02 times 10 to the power minus 4. 1.02 times 10 to the power minus 4, right? Moles per dm cubed. Now we have enough information now to work out the H plus concentration. The H plus concentration now is equal to the square root of 1.02 times 10 to the power minus 4 multiplied by 0.055. 0.055 here. Put that into a calculator. So square root of answer by 0.055 is equal to 2.37 times 10 to the power of minus 3. And now that's not our answer, remember, because we still need to work out the pH. 2.37 times 10 to the power of minus 3. Now put that into our... I'm aware that this is probably taking too long. I'm not doing this. I can do this in exam conditions, but I'm trying to speak and do this at the same time. So bear with me when I do this. I'm just trying to explain to you guys. If you know how to do this, great. This video is for people that don't understand how to answer these types of questions. I will do a video where I just go through exam questions directly, and maybe that video will be a bit more helpful to you. Or a bit more useful to you. But if this video was useful, please leave a like on this video. I tried my best, and yeah. So minus log base 10 of answer 2.62. And that's it. If I add this correctly, and that should be your final answer. Hopefully this video was helpful to you. Again, I always say that pH and pKa are the same. Under certain conditions, pKa and pH can be the exact same thing, but in this instance, they are not. Hopefully this video was helpful, and that is it.